Alright, before we start talking about tonight's content, you're going to see me as I'm talking at what will probably look like really random points, making notes in this area of the video right here. I'm putting those notes there to help me with when I later insert questions into the YouTube video. I don't want to spend a long time explaining this, but basically just know that those marks help me later on when I'm inserting questions. And just know that what I'm writing over here will seem random and has nothing to do with what you should actually be writing down or paying attention to. It just helps me later on. Alright, tonight we're talking about conservation of mechanical energy. Now I started talking about this today in class, unless we ran out of time, with the PhET simulator of the Energy Skate Park. A couple terms you should know about. Conservation means that the amount you have of something stays the same. So you conserve or don't lose the amount you have. So the word conserve is to keep the same or to not change. Conservation of mechanical energy. Mechanical energy is the total kinetic energy plus potential energy. So at a given moment, you add together how much kinetic energy you have, how much potential energy you have, and that is your mechanical energy. If all the forces acting on something are conservative, we'll talk more about that as the year goes on, but conservative means that a force doesn't cause energy to be lost to a system. Conservative forces are things like gravity and spring forces. Then mechanical energy is conserved. If you were ever to have a situation as far as the AP exam goes where mechanical energy is not conserved, the question would either tell you or it would be a non-conservative force that I had made you memorize was non-conservative. So just know forces do have to be conservative for mechanical energy to be conserved. And I will let you know whether those forces are conservative or not. But key takeaway, mechanical energy, Ke plus Pe. And as long as your forces are conservative, the amount of mechanical energy you have doesn't change. So in a problem, you might start out with all potential energy, say at the top of a cliff with height h. But then when you get to the bottom of the cliff, you have all kinetic energy. The trick is the amount you have up at the top is the same as the amount you have at the bottom. Now I like to think about this as buckets. So at the top, we have a bucket, and that bucket's a certain size. And at the top, our bucket is filled with potential energy. At the bottom, we have the same sized bucket, but now our bucket is filled with kinetic energy. And the bucket size stayed the same. So if you had 100 joules of potential energy up here, then you have 100 joules of kinetic energy down here. Same thing halfway. Halfway through the problem, we would have part of our bucket filled with potential energy and part of our bucket filled with kinetic energy, but our total mechanical energy would still be 100 joules Pe plus Ke. And again, this right here, Pe plus Ke, is total mechanical energy. All right, those are the concepts you need to know moving forward.